All right, guys, so here's the second half of the dividing complex numbers video. So we have two more examples on the back of that note sheet. So 4 minus 7i over 3 plus 2i, we have to get rid of the I in the denominator, called rationalizing the denominator. So we're going to multiply by the conjugate of the denominator over the conjugate of the denominator. Okay, so we have a binomial times a binomial, which means I have to multiply all the pieces. Just keep distributing. So 4 times 3 is 12. 4 times negative 2i is negative 8i. Negative 7i times 3 is negative 21i. And negative 7i times negative 2i is positive 14i squared. We're going to leave the numerator as gross as that is and focus on the denominator. Now, because I know that 3 times 3 is 9, I know that 3 times negative 2i is going to be negative 6i, and 2i times 3 is going to be positive 6i, because these are conjugates. That middle term, that I term, cancels. So, I can just move on to 2i times negative 2i, which gets me negative 4i squared. Now, let's go back to the numerator. If you see an I that has an exponent higher than 1, you know you have to simplify it. I squared is the same as negative 1. So now we have negative 1 times a positive 14 in our numerator, giving us minus 14. Okay? I'm just going to rewrite everything else for right now, and then I'm going to focus on combining the terms. Now, the denominator, same deal. I squared is the same as negative 1. Negative 1 times negative 4 is a positive 4. Now let's combine like terms. 12 minus 14 is a negative 2, and negative 8i minus 21i is negative 29i. In our denominator, we have 9 plus 4, which gives us a total of 13, and this is fully simplified because there's no I in our denominator. Now on to our second question. Our second question says 5 plus I over 9i. What's the conjugate of 9i? Well, it's actually negative 9i, because 9i is the same as 0 plus 9i, and our conjugate we know is just the change of that second sign, or middle sign, so it's just actually negative 9i. So this problem is a lot easier, even though it looks different from what we've been doing. Alright, so I've got 5 times negative 9i, that gets me negative 45i, and then I've got I times negative 9i, which gets me negative 9i squared. Now, my denominator, I have 9i times negative 9i, which is negative 81i squared. Remember, your I squared term is the same as negative 1. So in my numerator, I really have negative 45i, negative 1 times negative 9 is positive 9. And then I squared is the same as negative 1. Negative 1 times negative 81 is positive 81. Now this looks good because there's no I in the denominator, but it's not fully simplified because all 3 of these terms are divisible by 9. So we can simplify it just a bit more by dividing everything by 9 to leave us with negative 5i plus 1 over 9. And this is fully simplified. Now I know your note sheet says calculator break. We actually aren't going to do that this year. We're moving on to the last bit of our notes. The last bit of our notes is talking about simplifying radicals using imaginary numbers. So back when we did radicals, we said we couldn't take an even root of a negative number. Because that would not give us a real solution. So we would just say no real solution and move on. However, now we know about these things called imaginary numbers. So we can simplify radicals that have even roots, even indexes, using I. So let's look at the first one. We have the square root of negative 88. The square root of negative 88 is going to get me, well, negative 88 is the same as negative 1 times positive 88. Now, negative 1 times positive 88, the square root of that could be rewritten, I should say, as negative 1 times the square root of 88. What's the square root of negative 1? It's I. And now I have I root 88. And now I can simplify this problem like we used to. It's even, so I divide by 2. Even, divide by 2, even divided by 2, and 11's prime. So we're done. Then we look for pairs. Pair 2, so a 2 comes out. We already have an I out front. What's left inside is 2 times 11, or 22. And there we go. So basically what we need to remember is take out an I first when you have an even even root of a negative number. So take out I. So the square root of negative 45 is the same as I square root of 45. The square root of negative 5 is the same as I square root of 5. Now simplify. So 3 and 15, 3 and 5, rules of the game are pairs, 2 of a kind. You take out a 3, there's already an I there, we're left with the square root of 5. Over here, this 5 can't break down any further, so we just bring it down. Now, these are known as like terms. We have the same index, and we have the same run of can. So 3I root 5 plus I root 5 gets you a total of 4I root 5, and you are done. For this third example, take out an I in both cases first. So now you have negative I root 4 times 2I root 3. Okay? Multiplication, you don't have to have like terms to multiply. You can just multiply straight across. So a negative 1, technically, times 2 is negative 2. I times I is I squared. Square root of 4 times the square root of 3 is the square root of 12. Now, remember, I squared is the same as negative 1. And negative 1 times positive 2. Negative 1 times negative 2 is positive 2. And now we just have to break down the square root of 12. 2 and 6, 2 and 3, pairs, and you take out a 2, multiply it by the 2 outside, you get 4 square root of 3. There are 3 more examples on your note sheet. Go ahead and try them yourself and then play the video when you're ready. You should have gotten the following 3 answers. 4I square root of 3 if my work is above, 10I root 3 if my work is above, and 10I root 3 again if my work is above. We had a graded exit slip. You will need to do that even if you're absent. And we have our quiz next class. So practice, practice, practice.